messed up.
Awesome. Hi, Rishabh. Thanks for joining us. And for most of you, probably have some background idea about who Rishabh is, but a quick intro would be like, he and I met back together when we were in undergrad, and then since then he has worked at Microsoft Research, did a PhD at UCL. I was like a tech lead on recommendations at Spotify, and currently director of ML at ShareChat. So very impressive background, but I would love to hear your side of the story and what got you into machine learning.
Yes, so thanks, Sourabh. I think this is a very interesting conversation because I mean, like, as you mentioned, right? I mean, we go back to Bitsian days. We both went to Bitsilani for the undergrad, and I love like the journey you've had like at Google, Coursera, and I think like you're one of the first 10 engineers at Coursera, like one of the early engineers. And I think like I love what you're doing with like CoRise, genuinely, right? Because I think like getting taught from the industry experts, like I mean, like Daniel Tunkelang has been like on your course curriculum. So I think I really value like education from the people who have actually built these systems at scale. So love what you're doing here. Yeah, coming back to like the question, I think like, what got me into data and machine learning? I think this goes back to the Bitcoin days back in 2008, 2009. I was one of my internships was as a company at Inside View there. I was trying to do some linguistic analysis of news content. And we ended up kind of picking up, I worked with somebody who had a PhD in NLP. That's the first time I was talking with somebody with a PhD and like the rigor which they brought to the project. And we ended up kind of writing a paper on this. This is way back 2010. We submitted to ACL. Again, got a bunch of rejections, went through the grind of getting rejected. And then like finally it got accepted and like learned a lot in that process. And since then I've kind of stuck around in the neighborhood areas. So I started with NLP. And then during my PhD, I started to work on user understanding, like user intent understanding. So there's like massive amount of data, like which when users interact with these systems, they leave behind these traces of information, can extract about what task they're trying to do. And then we ended up developing these Bayesian hierarchies. So maybe it's like, if you're planning a trip to London, then that's a high level task. You're gonna maybe book some flights, get some visa. If you're a vegetarian, you're gonna look for vegetarian restaurants in and around London. You're gonna travel from your hotel. So there are different subtasks which people will do, right? But then like, how can I understand? Like if I look at a bunch of query logs, like I spend a lot of time at Microsoft Research working on Cortana and Bing data sets. So again, like millions of queries per day, like how do you make sense of this, right? So can I extract these tasks in an unsupervised manner? We ended up developing some of these Bayesian hierarchical models to extract these tasks. So I think since 2014, I've been near this user understanding, and intent understanding space. And then like right about after my PhD at Spotify, again, like user recommendations was the recommendations in music domain was one of the core topics. So back when I started Spotify, we had a contextual bandit model 2017, 2018, which we were deploying on the homepage to close to 140-ish million monthly active users back then. I mean, now it's scaled to like 400 million plus. Great growth. And but essentially, I mean, there like what kind of nuances are there across users? I mean, some users want to explore more, exploit more. Contextual bandits are great for explore exploitation problems. So again, started working on those problems. And since then, I've been like slightly more interested in like, what is it beyond users? Like just keeping users is maybe suboptimal. Then can we start caring about the creators, about the artists? And started leading the work on Marketplace at Spotify, transitioned into ShareChat, because I think like the creator ecosystem is going to be the next big thing. Hopefully you're going to talk about that later as well. But essentially, I mean, that's been my journey. Started with like slight bit of NLP, look at domain adaptation, started working on search, log understanding, extracting these tasks, and then switched into personalization and now into like user plus other stakeholders. Yeah. So that's been my journey. Like, again, like started working on small data, like a few million news articles and then like few million, 100 million users. And now at ShareChat, we have close to like 100 million creators, like billions of events per day. So again, there's been a nice curve on the data front as well.
No, that's awesome. Especially, I think like just seeing like how ML itself has changed with how data has changed has been like fascinating, especially from the engineering side as well. Like I would love to go back to the multi-objective problems, but before that, like one question I had in mind is like, you've talked a lot about like domain understanding before you start doing ML. And I think oftentimes like, that's like one problem. It's like, when you're learning ML, you're learning about all these techniques, but when you're applying, it's like a very domain specific thing. Would love to hear like how you think about like its impact on success of the work you're doing.
Yeah, I have my own very personal thoughts on this. Like, again, like I'm not, it's worth the disclaimer, I'm not representing any official views by anyone. These are just my own personal thoughts. I think a lot of like ML people, they end up like developing ML models for the love for math, right? And they're trying to kind of throw the ML model at the problem without spending too much time in understanding what the problem is about. So I think this is where, like, I mean, I highly encourage everybody doing machine learning, applied machine learning specifically, not to throw an ML model, but then like spend your time in understanding the problem domain. I think like one of the realizations I've had is that, look, I mean, if I don't understand my problem domain, I cannot formulate the problem well. And especially in these user-centric systems, right? You got to be very careful about what is the objectives you're optimizing for. So if you just put one ML model and try to kind of use it without understanding, then it might have a lot of like large scale impact, which is pretty bad because I mean, clickbaits are common, filter bubbles are common, right? I mean, people, they see that, oh, let's optimize for clicks, right? So then, I mean, there's a lot of like societal level bad impact which these things could have. So this is where at least the perception I have is that if we spend time understanding the different parts of a problem domain, be it understanding users, be it understanding content, be it understanding the suppliers, be it understanding what is good and healthy for your platform, that's going to give you wins. And over the period of time, I have tasted in my own projects like wins by just spending time understanding data. I'll give you an example. So, I mean, at Spotify, right? I mean, like 2017, 2018, when we had the bandit model. So there was some project we were doing with Munia. She was my manager, head of research at Spotify. So we were looking at like what kind of reward models do we use to train this model, train this bandit. So it's like, hey, I mean, I show you this content. Do you like it? If you stream X seconds, then okay, it's a good enough reward, right? But then there is enough nuances. Like, I mean, sleep music, I don't want you to stream sleep music for 30 seconds. That's too less. I mean, sleep music, you should stream for like 3 hours and go fall asleep, right? So then like this simple reward definition is not sufficient. So then I need to maybe spend more time in understanding my content. We found out that jazz listeners listen to jazz music much longer than an average listener. So you start seeing that there are these user level heterogeneities, content level heterogeneities, and my very simple looking reward function is like agnostic of all of this. Right. So it's not going to optimize for each of these categories and content and users in a good way. So then we spend time in like developing these co-clustering based techniques. We wrote a paper at the Web Conference 2019 on this topic. And we saw that like if you are very careful in designing this reward function, then you're going to get a lot of performance gains. Right. So again, you spend time in understanding your users, you do better. Like I love the evaluation experimentation setup as well. So when we are trying to understand user satisfaction, that's also where we said that, hey, if you don't understand the user intent, then maybe you don't like, you're not going to quantify satisfaction in a good way. There's a very nice example we found that, look, imagine that if the user is streaming some music and if they keep on skipping songs, but then it's like, hey, I mean, you're skipping a lot. Maybe you don't like the recommendations. That's not true. Maybe the intent is that you want to create a playlist for a party later tonight. So then you're going to sample this song, add to a playlist. Yeah. Right? So suddenly like the same interaction signal has very different interpretation condition on the intent. So if your intent is to listen to music right now, it's very different than if your intent to create a playlist for later. So again, like if you're not understanding these nuances, right, then like I don't think like people, at least in the applied ML space, can learn a lot. I mean, again, this is just on the user front. There's enough on the content understanding bit, enough on the creator bit. So I think like it's important to have a holistic understanding of your product and the impact, right? Like, I mean, on ShareChat, we keep seeing that people will just upload like random videos, like there's a fan rotating, 15-second clip of a fan rotating, and they upload it, right? Now that's zero creative value of that content, right? Should I show that to the user? Should I not recommend that, right? I mean, do we have enough content understanding in our teams, in our systems to maybe find out that the creative value of this content is pretty low, and maybe we should not recommend that? So I think all of these, I mean, again, like if your product managers are doing a good job, if you're doing a good job, then you understand your problem domain, you know where the money is at, right? And then you can do an analysis, find out that, hey, if I develop a model, I think there's definite wins here. Why? Because like, of course, the analysis is showing that. Now, the analysis is not causal, often correlational, but at least like investing time in that analysis often goes a long way.
Yeah, like I think the causality of actions is like an interesting question for me, which is like oftentimes you might see like in some sense what you're doing is there's a large objective function that's kind of ill-defined. And you're trying to do some factor analysis on what are potential variants here, which is what is your intent to create a shopping playlist? Is your intent to create something else?
Right.
My question is like, how do you think about like data collection then? Like there's
Yeah.
so much around like content, there's so much around user activity. Like what are systems that have worked for you?
Yeah, I think like one of the things which I've learned a lot from is just the fact that if we can collect some randomized data, right? Like randomized policies that if again, like maybe like some people like more discovery, less discoveries, maybe they like niche content, tail content, whatever. If I can collect some randomized data, again, like randomization does impact user satisfaction. So I won't recommend running a 10% test on that. But then if you have like a light 1% test, which is collecting randomized data, that gives you enough randomization in the data that you can pinpoint. There are certain situations wherein we would have shown that tail content, we would have shown more discovery, less discovery, more popular content, less popular content, some creative content, some crap content, right? So in that random data, you'll have enough nuances which you can dive deeper and extract insights from. Now, there's a big problem in the industry generally because the log data is very biased. Is biased by what the model is actually optimizing for right now. Now, if I have a new policy, if I want to try a new idea, then there's going to be a big difference between the logging data policy and the policy you want to evaluate. Now, there's a big difference then, like the log data you have, it's not going to give you that insights, right? Because you might want to find out, hey, did I ever show that niche content, niche created to this user? What's the impact? Oh, actually, you know what? My current model sucks on that. So then I don't have enough data on that topic. So this is where, again, like randomized data collection and using that for a lot of these analysis is going to be important. If you take a step back, look at what has happened in the web search industry. In web search, what we have done is like Bing and Google, they log the entire mouse cursor movements entirely. And literally, when I went to Bing, I saw the data. We could literally play a 30-second clip, which is the real-time cursor movement, like X, Y on the screen versus time. And this is what the user did. They clicked on this, they went this. I mean, you were reading that snippet on the web search, you're kind of moving your mouse around there. So the granularity with which I was exposed that, I mean, this is 2015. And again, I was a PhD student. I was like, hey, pro math heavy papers, love it. Let's do that. I went to Microsoft, I looked at the data, I was like, oh, this is amazing. Like the amount of user interactions we are logging and the amount of complexity, like the JavaScript thing, you need to log that across like millions of queries per day, right? It's insane. But then if you have access to that data, then you can find out, okay, what's going on? Where is the user getting stuck, right? What are the bottlenecks in your platform? So again, like we ended up developing a lot of these metrics on Spotify, on ShareChat. We try to understand, like, are you scrolling more? I mean, are you kind of clicking on something? Are you coming back on search, dwell time and click back? Quick back is a great metric. If you click on a result, you don't like it, you go back, right? So then if you're measuring the dwell time well, maybe there's a problem and like your dwell time estimates are incorrect. So then like your metrics are incorrect. So there's a lot of nuances here in like collecting the right data and even collecting randomized data that you can do a lot for good, almost causal analysis.
So let me ask you like two questions that are interesting follow-ups to that one. One is like, okay, you have like this 1% randomized trial, right. And you're obviously the 99% is biased towards your current model and current hypothesis.
Right.
Like if you're changing something, like what's like the rollout process in like, hey, are you like leaning more towards like weak label propagation kind of systems? Like what is like good best practice there?
Yeah, I think it's a very, and this is exactly the kind of topics we should be discussing in any of the courses as well, right? Like, how do you solve this problem? Like, do you train on this randomized data, or do you just ignore the 99% of your actual logging data? Yeah. Or is the 1% data enough representation to train your ML models, or just for evaluation, right? So I think this is where, like, I mean, just pure randomization is one extreme. No randomization is the other extreme. If you look at a lot of work going on in the counterfactual evaluation domain, so counterfactual evaluation says that, hey, give me these propensities, give me the scores, the log the probability of you taking that action. And like, look, I mean, you pick up a recommendation, you start showing it. Now there's a score behind it. If you're logging the score, then I know with what probability you are certain that the user will like it or not. If I have these actions logged, then I don't need access to this randomized data entirely. I can do something called inverse propensity weighing. So I can do a 1 upon action probability and then like weigh my examples appropriately. What would happen is that if there are certain examples wherein like the probability of you taking that action is less, so because it's a denominator, the variance blows up. What's my point? My point is there's a lot of effort which has gone into designing these pseudo randomized trials, wherein you're not purely randomizing. Maybe you're replacing the second rank item with like some random content, right? And maybe sometimes not the second, maybe the fifth rank, right? So then can I use this data to extrapolate some information? So that's a lot of work on data collection and using that randomization. Now, two things we can do with it. This is generally recommended. One is that you can train your ML model on this data. And again, it may not be big enough. It may be good enough. You can mix it up. The other is you can develop these unbiased estimators for evaluation. So even if you have a different policy, right, you're going to evaluate your new recommendation model in the offline world. Yeah. Now, correlating this offline metric to the online metric is a nightmare. And one of the things I was literally blessed to have was in 2019, May-ish, I developed a offline evaluation data set for myself for the work I was doing. It worked, right? I mean, it took a while to get it to work, but then once it worked, I never touched it. It was the most precious resource I had as an engineer, as a scientist, that, hey, I mean, my offline and online are slightly correlated, directionally correct. I'm not going to let anybody touch it. So again, like as an engineer, right? I mean, you got to rely on, I mean, I'm doing a lot of experiments. I want to make sure that my offline estimations are correct and they're predictive of what's going to happen online. So this is where, like, what has happened is a lot of people have developed these unbiased metric estimators, which are more predictive of online success than your traditional like accuracies, NDCGs, and all these metrics. So essentially, like, I think like again, it's worth it to collect this randomized data. It's worth it to spend time in developing good offline online correlation, because again, that gives you a lot of, like, it's a fruit which keeps on giving. It's a tree which keeps on giving you fruits, essentially.
Right. So one follow-up question, which I think was like, often you don't have that many users.
Right.
And like, what are, like, do the same learnings propagate to, like, say, a Series A, Series B company?
Yeah. So that's a great question. I'm not sure if I'm like well placed to answer it, because all the problems I've worked have been on like massive data sets. But I would point out that if you look at like something's going on in the causal world, Julia Pearl is a great, I mean, again, he's a father of modern probabilistic graph legal models. And he's also like now the father of like causal inference, at least in this DAG, directed acyclic graph community. So what's going on there is like, they're trying to, in a low data environment, can I create these causal graphs? So again, look, if you don't have data, then you got to have domain insights, right? Yeah. If you know more about your domain, you can encode that domain insight in a structural causal graph. And again, like, I mean, God knows how people are going to decide what the causality structure is in the graph, and that's again a research topic. But then what ends up happening is that if you're encoding your domain expertise in a causal graph, then there is something called do calculus. So do calculus gives us these like causal rules that, hey, can I intervene on this variable and find out what happens without actually observing that data? So literally, like, do calculus it's literally 3 rules of calculus, which is in a new mathematics, which was introduced back in 2014-ish by Julia Pearl and one of his PhD students, Elias. He's now a faculty member at Columbia or somewhere. So essentially, what that allows you to do is, like, if you have this causal graph, then I have the math ready to show that can I extrapolate about this variable without actually having that observational data. So I think, like, if you're low on data, then you can go this causal structure out, apply some do calculus math, and that will give you an estimate that is this quantity estimatable from the data you have without running an additional A/B test. And this is, let me take a step back, right? Very clear differences. Big companies have access to large randomizations. So I don't need to develop that causal graph. I can do a randomized A/B test at scale and get my estimates. But if I don't have access to that, I'll have to rely on this causal DAG structure and hope that the pre-post intervention math works out for me and I can get that estimate. So there is like enough meat already on both the sides of the table for you to go grab. But again, it's not the most easiest papers to follow. I spent a lot of time during my PhD trying to understand that. We had an intern, Olivier. He's now at Amazon, and he's a postdoc at Amazon right now in the UK. And we spent a lot of time in like doing this disentangling in a causal DAG structure way. So again, I mean, I learned a lot during his internship with us at Spotify. So again, not the easiest math to understand, but then well worth it, especially if you're in this low data domain, or if you manage to get somebody to do that course on CoRise as well. Again, I'm shamelessly plugging in, but I think like if there's a course on this topic from one of the industry people, I would just sign up for that.
Yeah, no, that's awesome, and it's something to keep in mind for us. I think one, like, coming back to like, I think the topic of recommender models, obviously, like, one of the, what are like problems that you are excited by, like today? Like, I guess there is like an applied world of what you want to go apply.
Right.
And then there's like, what is like, if you had to go back to your PhD again, what would you work on?
Yeah, if I had to do my PhD again, I would literally take up microeconomic theory, to be honest, because I think like there's like, I mean, the recommendation systems are having like economic impact at the societal scale, right? So again, like if you're looking at Postmates in the US, Swiggy in India, Deliveroo in the UK, right? I mean, a lot of these delivery partners are delivering content, delivering like food or whatever to you at your doorstep. Now, how much money does a restaurant earn? How much money does these delivery partner earn, right? That's decided by the homepage recommendation model of the Deliveroo, of Swiggy, of the Postmates, right? So again, of the Uber Eats of the world. Now, again, like I think, are these systems getting developed with the right understanding of like the economic implications on the society? Maybe, maybe not, right? Do we have qualified people who understand the economic theory well enough to be able to make those decisions? Maybe, maybe not, right? So I think like the way recommendations community has evolved is like, again, not just recommendation, even search, right? I mean, all of it was very user-centric, right? I mean, like on Google search, I want you to find the results and then like go disappear from Google right away, right? The more time you spend on your google.com, then that means that you're not happy with us. So we've been very, very pro users. And now I think it's time for us to wake up that, hey, I mean, it's not just a user-centric world. It's a world about creators, about your suppliers, about the platform economics. So how do we design these multi-objective systems, multi-stakeholder systems? So there's one theme of work, which again, very interested in, is what's the long-term sustainability in this multi-objective, multi-stakeholder domain. So that's what I've been doing at Spotify. That's what we are doing now at ShareChat and Moz itself. This one piece. The other, zooming in, is this huge wave in the creator ecosystem. So again, one of the reasons I took this job at ShareChat was to put myself into facing these creator ecosystem problems. Now take a step back. Close to, like, I think by some estimate, some magazine, right? I mean, close to $105 billion industry, the creator ecosystem right now, close to 15 billion or 20 billion, the current influencer marketing world right now. So that number is like skyrocketing. It's just going to go vertical. If you look at like things like Spotify has close to 8 million or something, 8 million artists. YouTube has 51 million channels. ShareChat has close to like 50 million creators. Moz has close to 100 million creators. Like OnlyFans has like 1 million plus creators. Like there's a lot of people earning a lot of money by just being creators, right? So again, you and I are recording this content. We're going to upload it hopefully on YouTube. And we are also creating content for the masses, right? I mean, the course we are creating, I mean, I'm creating that course. I'm a creator for the community. So what's happening is that in the industry, these industries are just going to go vertical. That, I mean, the amount of money invested in this, the amount of money which creators are going to make from these platforms, I mean, that's going to increase a lot. But as a recommendations community, have we given enough focus and attention to this topic? Maybe not, right? I barely see any papers talking about like the sustainable growth of these creators, right? So again, I mean, LinkedIn doesn't want a one-hit wonder that you post one thing, you get like 1,000 likes, the next post gets 0 likes, right? I mean, you don't want that if you're a TikToker, if you're a Moz creator or an Instagram Reels creator. So how do we kind of understand the nuance of the creator ecosystem and support it from the right methodology, right? So again, marketplaces, creator ecosystem, these are some of these topics. The one thing I definitely would want to zoom in also in this, and I'll wrap up this part at least, is this need for more inclusive recommendations across the world. Now, look, I mean, I'll give an example of real world and the digital world. In real world, you have these like regional geographics, right? You have the boundary of Asia separating Europe. You have like UK here. You have the US and all, right? Now, on the internet, I think like the language is the boundary on the internet. So, I mean, we don't have that geographic boundaries, but then we do have language barriers, right? Now, if you take a step back, then all of the content I consume is mostly from these applications which are pro-English, right? So again, like Facebook, Instagram, a lot of, I mean, we are creating courses in English, right? I mean, there's no regional content on CoRise, right? I mean, it's not a problem you're going to face in the next few years at least. But then like some of these other applications have been around for more than a decade, right? They're still very heavy on English as a platform, but then like a lot of regional users across, I mean, look at Middle East, look at India. India has 15 languages. Look at Europe, right? I mean, Swedish people can consume a lot of Swedish music. I mean, local music culture is an important deal for them, right? So, but then are these recommendation platforms giving you that content in the regional languages? No, they're not, right? And it's not a very easy problem. Why? Because like there are different users across these languages, different regions, right? It's not just users, the user expectations are different, the habits, the behaviors are different. It's not just about behavior, the perception of recommendation quality is different. And not just user, the content supply is different. Do you have enough creators in each of these languages? No, you don't, right? Do you have enough supply quality in those languages? No, you don't. So the point is that there's a lot of like different economics at play across these regions. None of these platforms are catering to that. So how do we solve? It's hard enough to build one recommendation engine, right? Imagine like it's a nightmare to build like 15 recommendation engines, which I'm facing. I mean, this is my day job. At ShareChat, like we are in 15 languages, then how can I develop these recommendation surfaces across different languages? And then like you have some popular languages, some tail languages, maybe you can do some transfer learning, domain adaptation. I know Satvik is on the call, so maybe that gives him some ideas of modeling his next project internally. But essentially, like, I mean, there are these nuances which make the recommendation systems inclusive for the entire community, right? So the next billion users coming onto these platforms across different languages, like, can we be more inclusive to them? So I think like that's the, I mean, again, I would love to kind of continue working to make these recommendation platforms more inclusive.
I think that's such a good point. And like, I think there's like this whole debate around like how do ads affect this same ecosystem as well, because a lot of these platforms are also ad platforms. So there's like a clear like, in some sense, like the objective function is like very complicated in like what are aligned incentives for all parties.
It is, but I mean, look, I mean, I'm going to complicate it slightly further. And again, this is huge disclaimer. I don't represent any other's views, just my own personal. Now, I think there's a nice like political flavor to this, right? I mean, Trump getting, I'm going to go into very sensitive content, so apologies if it upsets somebody. But look, I mean, Trump got deplatformed, like the sitting president of US got deplatformed from one of the biggest social networks in the world, right? Now, again, like, I mean, all of these platforms have a US CEO, right? I mean, Twitter has a US CEO, Facebook has a US CEO, right? If this could happen to the US president, imagine like how scared these national states of head would be across the world, right? So then do they want to have their own crowd masses dependent on a US-centric social network? Maybe not, right? Imagine what's happening in China. China doesn't have any of these big internet companies in China, right? They have their own WeChat, they have their own Twitter, they have their own, I mean, Russia has their own Facebook as well, right? So again, like it's just a matter of time that companies start realizing that, hey, we need this national stack. And that national stack means that I need to have my own social network. But then I'm a small country, like Middle Eastern countries, maybe they cannot have their own social network, right? Maybe then they're going to pull together. That maybe countries in Europe, countries in Middle East, India and all, they start combining, right? So if you take a step back, then I do think personally that there's going to be a wave of nationalism, which is going to impact the tech industries. So that like there's a need for developing these regional aware recommendation systems, social networks, mostly from a user perspective, but also from a political perspective. So again, as you mentioned, like the objectives are nuanced. Imagine like the political landscape impacting the design of these as well.
Yeah, no, that's such a good point. I think with that, moving on to like a few easier topics. I guess you've been passionate about teaching and like sharing knowledge. You've done like a whole bunch of conference tutorials and everything. Would love to hear more about like your course and like what got you into like teaching again.
Yeah, I think like, yeah, I mean, on my website, it's like, I had a code, this is back in like the early days when I was applying for PhD, applying for internships, sending like 100 mass emails to people that, hey, can you give me an internship? I don't have good grades. So I had this code, like if you can't teach it simply, you don't understand it well enough. So I think part of the reason why I love to teach is just make sure that like, do I understand nuanced, complex in an easy enough fashion? And can I explain it? So again, like, can I explain these concepts in a simple way? Look, I mean, we would rather live in a world wherein these systems which are impacting users, they are understood by the users, right? So again, I think like the responsibility which a lot of these leaders developing these systems have is not just to make it easy for the industry people to understand it, but then how do I make it easy for the actual general masses to understand it? Why? Because otherwise we can't have regulation, we can't have policy development if the masses don't understand these things. That's a high level thing. Let me make it more realistic. More realistic, I think like there's a huge gap. When I went from my PhD to Spotify, right? I mean, again, during my PhD, when I went to Microsoft Research for the internships, I was very, very pro ML, pro math, like let's sprinkle some math on the papers and get it accepted, all that, right? I went and I realized, oh shit, evaluation is such a nightmare, right? I mean, metrics are such an important nightmare. And again, you can't make a model work if you don't have the evaluation, if you don't have the metrics, right? So I think like there's a void between what we get taught in the university and what is needed in the actual industrial work. So, and again, who should I reach out to, right? Are there people teaching that course back in 2017? Right? Like we had Andrew Ng teach a lot of machine learning, but there was no course I could understand, like there's no evaluation courses, evaluation metrics, the nuances of like feature engineering. You're talking with the head of machine learning at DoorDash a few weeks ago, right? So, I mean, that gave me a lot of insights about feature transformation, feature engineering, right? Again, there's no course I take in the university as a student, which teaches me that. So I think this is why I huge respect to like companies like CoRise who are kind of bridging that gap, that there's a void. Let's bring in the industry people who have solved these problems, and then they can have a very nice conversation with the people who want to solve these problems 1 or 2 years down the line. So that's the pitch. The reason why I think like the recommendation systems course, I think like people still think recommendation as a Netflix $1 million prize, matrix factorization, right? I mean, that's a 2-decade-old world. I mean, there's a very nuanced systems which we are developing across each of these big companies. So I think with the course, we're trying to get an idea that can look at the candidate generator, look at the multitask predictions, look at the evaluation, look at the in-session personalization, user representation. There's an ecosystem which we have to design. So just trying to give a flavor that, hey, I mean, this is what it takes for you to design these recommendation systems. These are the problems. These are the areas. If you're interested, go and deep dive, right? So again, we're doing a lot of hiring at ShareChat. Again, this is not a hiring pitch, but a genuine thing we need is like people who are more mature in understanding these problems, right? So again, it's in our interest to get the new talent upskill with these topics so that they can convert a lot of their machine learning knowledge into actual applications, which are going to impact like millions and millions, I mean, 100 million plus users, right?
Yeah. No, I think that's definitely true. Like most courses you like think about in university are still like collaborative filtering, we're done. And
Right.
but like deep learning's changed like a lot of things.
Right.
Problems have gotten more complex. There's so much more data that there's a ton to learn. And like the big companies have moved. Like at this point, like all of the new systems that are being built are just not in the same paradigm, but like teaching's been lagging behind a bit. So I think we have about like 10 more minutes. So I would like one potential final question for you is, okay, we've talked a lot about like the importance of like multiple stakeholders. Okay, one model or multiple models?
No, yeah, I think this is where one model versus. No, I definitely, I mean, I cannot justify, I cannot sleep at night if I say one model, right? I mean, to me, it's like not one model, but multiple models, not just models, right? I mean, it's like not one task, multiple tasks, not just one task, right? Not one objective, multiple objectives, not one stakeholder, multiple stakeholders, not one metric, multiple metrics, right? I think like we got to be kidding ourselves if we think that these complex user-centric systems can be governed by one model. No, they can't. This is what happens. If you optimize for clicks, you're going to get clickbait. You're going to get like polarized content on different platforms, right? So there's a lot of bad things which happen when you over trivialize these problems. And I don't want to live in a single model world. Why? Because I want to live in a world of 100 predictions, right? I mean, I want to predict, like you come onto a platform, are you going to stay? What's your intent? You generally like discovery. Do you like discovery right now? You generally like popular content, but do you like popular content right now? Or are you looking for more like tail content, right? What's your intent? I don't know. I mean, on search, you're typing in query, in recommendations, I don't know what your intent is, right? You're just on the application. Can I predict your intent? Now, are you going to stick with your historic preferences, or is there some trending content which you're going to use right now? How long do I have you for? I mean, what's your session length going to be? Are you going to abandon soon? Are you going to stay on my platform for 15 more minutes? If yes, then maybe I can defer this ad. I would have annoyed you because I have to earn money. I'll have shown this ad now, but then I know that, hey, this user is going to stay for 15 more minutes. I can defer that ad, right? So look, there's a lot of these predictions, right, which we are making on the fly. So you come in, you spend 10 minutes, we're making hundreds of predictions, right? So I don't imagine how in a world we could live with like one model, one predictions. And I think this also points to a disconnect between the ML industry and these complex recommendation industry, because there's a lot of like noise on Twitter. Again, love the industry, love all the work which NLP and like the ACLs of the world, the ICMLs of the world are discussing. But then like the huge impact recommendations is having on the society, right? And the nuances which we have here, I mean, they're very, very non-trivial problems. And this is where like, I would rather make 100 predictions while you're on the platform to personalize your journey, to give you a much better enjoyment while you're spending this time here, right? So again, definitely not a one model person at all.
No, this is super insightful, and the clear contrasts and like the challenges in this world versus like how we've seen like pathways and other improvements in NLP. And I think it's just maybe you build on top of pathways, etc. Awesome. So I think we have about like 7 or 8 minutes. So I would open up to like audience Q&A, and I think maybe we can start with like Tim. You've had multiple questions, so or I guess there's one question, and then Tim, I can come back to. And more, instead of predicting completely on your own, what are like your thoughts on asking directly and using natural language response to predict?
Yeah, I think I love this topic. I think like one of the things which you realize Spotify and ShareChat we are doing, right? Is this space onboarding. Like even if you're as a new user, right? We show you this platform. You show that, hey, here are these creators, here are these topics, here are these artists. Which one would you want to consume? So it's not just a static, right? We're doing some active learning on top of it. You select some artist. Now, instead of you going back, I'm like, hey, I have you for 5 seconds. Maybe I'll ask a bunch of other questions right there, right? So even the taste onboarding you do when you sign up to this platform, that's the conversation, right? So that could have been a one-off conversation wherein you pick a few artists and that's it. But now, like what we have done is like this, like dynamically changes. You click on a few, we change the remaining, right? So this is us trying to find out more and more from that one conversation. So again, there's a lot of value in asking users in like various forms. At Spotify, we did this like in-app surveys. We try to understand what you're trying to do and are you happy with this or not? So even on ShareChat, right? We do a lot of user studies. We understand how users are consuming the app, and not just users, how creators are consuming the app. What is their expectations? So this conversation is majorly in the implicit understanding domain. We're going to cover that in the course as well. That can we look at implicit interactions? Like you never tell me I'm unhappy, but your dwell time decreased, your session success decreased. So then I know that you're not happy, right? So there's going to be a lot of these implicit conversations between the user and the system. There's going to be some explicit wherein you're explicitly giving a thumbs up, thumbs down, or like explicitly telling us that these are my tastes and I'm doing a mini conversation there, or even like user research on the other extreme. I mean, I did not understand and appreciate the importance of user research until my recent jobs, that the amount of insights you get by just observing users work your app and then asking these questions, like trying to drill down trying to formulate the initial content hypotheses, right? And then using that to kind of guide your ML model journey. So again, there's a bunch of conversations happening across the spectrum.
Yeah, no, this is super interesting. Ankit, I can take this one. What should students do to stay on top of the field? I think they're definitely like, Rishabh's not going to say it, but his course is amazing. And as for someone who's firsthand seen it getting built, that would be like an amazing resource. There's like interesting conferences, like KDD is like a much more applied conference than what you would see at like a NeurIPS or an ICML. There's like Rexus. Those are like very interesting like areas where there's an industry track to the conference. Right. So if you're more into the applied world, that could be potentially an interesting place to check.
And Twitter. I mean, follow people on Twitter as well. I mean, they keep posting a lot of like crazy stuff there. This is nice.
Yeah. Awesome. Mohit had this comment around, in case of an app like Swiggy, there are multiple shuffles on the homepage. And wouldn't there be one model in general and a modification layer? I think so. I guess a reframing of the question is like candidate generation and then multiple ranking tasks, or
and also like context awareness, right? I mean, you have multiple touch points. So if you look at an app, right, it's not like one model, it's like multiple surfaces, and each surface is optimizing for something else. And I think like the way we have been designing these systems at ShareChat is like, can I have an orchestrator? The orchestrator is going to create this whole page for you, right? If you go to Google, if you type in a query, you get like some results, you get some ads, you get some related suggestions, you get a Wikipedia panel on the right, you get some news articles, right? So it's a very heterogeneous mix of elements, and like 5 different types of elements, right? So this is how you should start viewing as some of these homepages as well, that, hey, there's going to be a whole page optimization layer, which is going to be the orchestrator, and it's going to bring in a holistic value to you. It's not just like find the 10 best items to ensure that. We got to be diverse in maybe like your intents are heterogeneous. I'm going to make sure that we're covering your intents. We're making some suppliers, some artist objectives okay as well, and some like maybe strategic content, which is great for the platform economics. So I think like the way to look at it is that, do you have a global orchestrator model, which is optimizing the entire homepage, which is using each of these like individual models, optimizing for one specific objective? So I think that hierarchical modeling is something which is, I've seen it pretty commonly used across industry. And again, the systems you're building at ShareChat is also doing something similar now.
Yeah, awesome. Gaurav had this question around, does the course cover evaluating the intent of the user, which is like majority intent, majorly intent, latent?
Yeah. So, I mean, we do touch upon like, we do touch upon intent understanding in the course, and evaluating the intent is, again, as Gaurav mentioned, like, I mean, intent is latent. We never get to know that, right? So I think some of the things we're going to touch upon there, again, the short answer is that you don't need to always predict the right intent, but then like the intent prediction is for a downstream task, right? So if I can make the prediction and then use it for a downstream task for better recommendations, better personalization, then you can do a lot of this indirect evaluation. So often in the industry, you have these problems which you cannot independently optimize, you cannot independently evaluate, but then like you rely on these downstream tasks. And again, like evaluation is a bit of a mess there. So we're going to touch upon some of those evaluation nuances as well.
Yeah, and so the next question was, how do you take into account like the multiple phases of bias in model evaluation?
Excellent question. I don't think there's like a 2-minute answer I could give, but this is where a lot of like effort on debiasing goes into play. I think like the industry has done an amazing job at debiasing. Like, I mean, position bias is something we started with, that like if you show something on the top, of course it's going to get a lot of clicks, even though users didn't like it, but they have this trust on your system that like if Google is showing this at the top, then that means this would have the correct answer. So there's a lot of this position bias, there's a lot of like popularity bias, the vectors you train, right? The embeddings of the product vectors or the item vectors you're training, that's also heavily biased by popular content. So if somebody says that, hey, I'm not popular, my model is not biased, they're just kidding us themselves, right? Everything is biased because like you're training a model, maybe you're training a model on like popular music or popular content genre, right? And then your ranker is biased towards that content. Again, one of the things we realize at ShareChat, like devotion and wishes are great for sharing content off the platform. Now, again, some of the other categories, you don't share that stuff. I mean, on LinkedIn, right? I mean, if somebody posts that, hey, I moved jobs, you're not going to share that post. You're going to like it, comment on it. But then if somebody posts a nice tutorial or this video, they're going to share that, right? So different category have these biases, and the ranker is going to just go like ballistic, right? Oh, I can't understand these nuances. So then there are these strategies wherein you can either account for that bias in training data, training sampling strategies, or you can kind of develop these loss functions, which are kind of accounting for some of these, or you can post correct it. So there's a lot of like calibration work going on in the industry as well, in the ads and in the recommendation industry, which try to deal with some of these problems. Excellent question, by the way.
Yeah. So there's a question from EE. Traditional models like collaborative filtering has predictions that are mostly around similarity between users or user items or item items. Deep learning based methods obviously can capture more data. They use learning to rank and generate candidates, etc. Are recommendation systems evolving in terms of like application? So I think the short answer is yes. And I think like my view on the world is like we're basically seeing like similar techniques be applied to like a wide variety of problems. Maybe
I think this is a great question, and I would like to combine it with like Alexi's question. I know Alexi personally he's now at ShareChat. I mean, about to join ShareChat at Yandex right now. I think like he mentioned the great point. Like I mean, the question EE mentioned is that deep learning, learning to rank, and Alexi's point is like maybe deep learning is not the best for LTR, GBDTs are best, right? So I think like we've realized over the period of time, like 2014, 2015, a lot of these like Kaggle and other competitions were won by FFMs, like field aware factorization machines. These machines account for interaction effects across these features. Now, I mean, again, like click-through rate prediction in the ads world has really kind of extracted a lot of juice out of these FFMs and GBDTs of the world, right? Because they account for a lot of these feature interaction effects. Now, but then like deep learning has come back with like these transformers and set transformers, wherein it's like, hey, if I apply a set transformer, I can do a lot of like self-attention blocks, which are going to account for a lot of these like cross-item interaction effects as well. So again, I think like I won't recommend one versus the other, but making sure that your models are aware of these interaction effects across these large feature spaces, I think that's very, very critical for good recommendation problems. And you go do it via the transformer way, or you go do it via the FFM or the GBDT way. I think like accounting for those interaction effects is a definite must to do.
Yeah, awesome. Unfortunately, we're kind of out of time, but if you have more questions, you can reach out to me on Twitter, LinkedIn, wherever you can find both of us, and we would love to take them there. And thank you so much, Rishabh, for taking the time. It was such a fun conversation.
Same here. Thanks everybody for joining, and thanks. Sort of loved the conversation. Yeah.
Yeah. Thank you so much.
Thanks.
Bye.
Bye.